Courage was needed to fly early airplanes. Outstanding courage and little else. The low performance of pioneer aircraft made relatively light demands on the pilot's reflexes, coordination, and judgment. The first half-century of flight brought enormous advances in aircraft performance and parallel demands for higher pilot performance. Oxygen, thermal clothing, and automatic devices helped create the environment needed to keep the pilot physically and psychologically fit. Today, with still higher aircraft performance, environmental control is more essential than ever. The pilot's faculties, efficiency, and capabilities must remain unimpaired, regardless of the flight conditions encountered. The design of environmental control systems for manned aerospace vehicles must be predicated on detailed knowledge of how the human occupants will react to high-speed, high-altitude flight. If we are to furnish the pilot of the future with adequate protection and utilize his abilities to the fullest extent, we must increase our understanding of his psychophysiological responses to flight conditions. In the Space, Environment, and Life Sciences Laboratory of the Paul Moore Research and Development Center at Republic Aviation, a program is underway that will provide answers to many questions in this area. Dynamic biomedical monitoring, employing advanced telemetry techniques, is an important feature of the program. The initial step of the current program was an experimental effort superimposed on design justification flight test activity. The selected aircraft was being subjected to maximum aerodynamic stresses called for in the design. Using Republic's standard telemetry equipment, critical points in the structure were being monitored. The circumstances offered a unique opportunity to obtain interesting and important data about the reactions of the pilot under especially high stresses. So he too was instrumented, and 2 transmission channels were assigned to biomedical use. One for the pilot's EKG, and one for his respiration rate. Within the limits imposed by the equipment available, the results were highly satisfactory. But a system better suited to the special requirements of biomedical monitoring was needed. Research objectives were defined, equipment specifications prepared, and an entire new system engineered. Today, the program is moving forward rapidly. This is how a subject pilot or astronaut is fitted with sensors of various types. They connect directly to a newly designed miniaturized unit built into a vest-like garment to be worn by the subject. This package contains all the electronics for amplifying, conditioning, encoding, and transmitting the impulses that reflect the pilot's psychological and physiological responses to changing conditions. The unit is self-powered, permitting unhampered activity by the subject. Ground station equipment designed to Republic specifications receives and decodes the signals. By using the PAM-FM technique with a carefully selected sampling rate, the required versatility and flexibility are achieved in the system. 15 channels are available, including one whose bandwidth is sufficient for voice or phonocardiogram transmission. Instrumentation is provided for visual observation in real time, and a permanent record is furnished by sophisticated write-out facilities. This chart shows a subject's heart action and respiration. Interpreted in connection with the time base and with a parallel record of the flight parameters, specific variations in response can be related to changes in stress or environment. It is expected that use of the coded information can be greatly expedited by coordination with Republic's electronic computers. Instantaneous diagnosis based on computer reduction of telemetered data is a research goal. The work proceeds on many fronts. In the high-altitude chamber of the laboratory, where aerospace conditions can be accurately simulated, a subject is undergoing a pulmonary function test. Current studies are directed toward separation of the psychological from the physiological manifestations. A prime objective is the development of sensors more suitable to dynamic monitoring than the clinical sensors now in use. Republic's telemetry system is designed to accommodate such improved sensors as they become available. In future space systems, man is destined to be the most essential component. He will be asked to accept an increasingly complex role in the system, and at the same time, he must face constantly mounting hazards and psychological stresses. The overall program of dynamic biomedical monitoring at Republic Aviation is dedicated to ensuring the survival and proper functioning of crew members assigned to future flights.